Hello world! Welcome back to another Hack This Site walkthrough video. In this video, we'll be walking through the Steganography mission levels 1 through 10. Let's get into it. We'll start off with mission level 1. This is an encoded message. The only tip you get is 2 null bytes. Go ahead and save this image to a folder of your choosing. I have it right here. Then you're going to want to open this up in HXD or some other hex editor. Then we're going to search for double null bytes within the hex source code. So we're going to do Control F, select hex values, do 00 space 00 like so, and then select our search direction as all, then click search all. And this will canvas the entire file, searching for that double null byte pattern. The excerpt that we're interested in the results here is at offset 471. If you click that, it'll highlight it here in the hex source code. And you're going to notice that there's a bunch of 16s and 17s in between 2 double null bytes. That is the excerpt that we're interested in. It's a block of binary that is masquerading as hex, so all we need to do is replace the 16s and 17s with 0s and 1s respectively. So we'll copy that excerpt and we're going to go to CyberChef. Paste that in the input here. Then we're going to search for find and replace. We're going to replace 16s with 0s. Do another find and replace. 17s with 1s. And we'll do one more just so we can replace the spaces. That way it just looks nice and clean. Then you're going to want to switch the input with the output like so. And you're going to want to clear your recipe. Then you're going to want to look for the from binary operation. Drag that into the recipe. And you're going to get what looks to be some unreadable text here in the output. Now, I want you to take a look at our byte length. It's 8, right? Because typically when we have a byte or a character, it's represented by 8 bits, or 1 byte. The length of our input is 55. It needs to be divisible by 8. 55 is not divisible by 8. However, 56 is. So at each iteration of our input, we need to try 0s or 1s until we get something readable, and then we can try that readable text as our password for this challenge. So we'll start with 0s, and we'll start with 1 right here. That didn't give us anything readable. We'll delete that. We'll go to the next index. That's also not readable. Next index, not readable. Next index, not readable. Next index. Now we have something readable. But we're going to skip this one because this actually doesn't end up being the password, and there's no need for us to try it if it's not the right one. You can try it yourself and you'll notice that it doesn't work. So, next iteration. This is the password that we need. So we'll copy this, paste it in here, click check. If you get the go on button, that means you've gotten the correct password for this level. If you click go on, it'll take you to the next mission level. So this is mission level 2. Did I hear that correctly? What we're going to do here is we're going to view the source, and we're going to scroll down to where our challenge description is. You're going to see your Steganography header right here, which is this right here. And then you're going to see an embedded source right here that does not show up underneath Steganography. We're going to open that in a new tab, and you're going to notice that it is indeed a WAV sound file. In order to download this, all we're going to do is remove the view source prefix and press enter in the URL, and you'll get a download for it right here. Then you're going to want to take your file wherever you put it, and you're going to want to open it up in Sonic Visualizer. We'll just drag and drop that in here. And then you're going to want to go to Layer, add Spectrogram, all channels mixed, and in the spectrogram lies our password. Now it is a bit difficult to read, and you might get it wrong a couple times because some of the characters are hard to distinguish, but with a little trial and error, you should get the right password. So we'll bring this over here, and we'll open up our challenge page again. We'll type in the password as it's shown here. JB298ABC9QB2. We'll click check, and we can go on to mission level 3. Look carefully, it's obvious, just not at first sight. Go ahead and save this image to wherever you want, and we're gonna open that image up in Paint. And all you're going to do for this one is click the paint bucket and then just select a color that's lighter or darker than the one that's in here. Then fill in somewhere randomly in the background, and you're gonna see your password in plain text right here. So we'll go back to our challenge page here, and we'll type that in N38F298HSJF, like so. Click check. And we can go on to mission level 4. I am being hexed. Alright, go ahead and save this image to a directory of your choosing. I'll open that here. And then what you want to do is, once again, open this in HXD. Then if you scroll to the bottom, you're going to notice some binary data that we can decode. We'll copy that and paste it into CyberChef. Look for from binary. And there's our password for this level. We'll copy that, paste it in here, click check. And we can go on to mission level 5. We have another image here. You're going to want to go ahead and save that to wherever. I have it right here. But this time we're going to start off by trying to solve this in my Kali VM. So we're going to navigate to where I have the file stored in the Stego 5 folder. You can see the image right there. Then you're going to want to run the LSB tool ZSteg on the image. Notice that didn't come back with anything. Well, if you just run standard ZSteg without any flags on an image, it's only going to perform the most common LSB shifts on that image. What you want to do is do ZSteg TAC A, which will try all known LSB shifting methods on the image. Then you're going to want to scroll up until you find this SYNAC P right here. That looks very interesting, right? Well, if we copy that and try to check it, and I actually forgot to put the S there, it's not going to work as our password. If we take a look back at the string itself, well, SYN and ACK are parts of the three-way handshake, but usually it's SYN, SYNAC, then ACK. So maybe this third packet flag right here is some other three-letter abbreviation. Now there is a PSH flag, and if we look up what that is, if we scroll down here, it says that the PSH flag in a TCP packet indicates that the data is urgent and should be sent immediately. Well, let's try PSH. That didn't work either. So maybe it's another network flag entirely, and the P was just a byproduct of ZSteg, and it's not actually part of the password. Well, there is one other thing we can look at in the image to maybe give us a clue as to what that third flag is. If we open up the image in a photo viewer or whatever, and we zoom in, you're going to notice that there's binary in the background behind the letters. Now, not all of these are readable, only about 4 lines are readable, and we can see that there's a 0 cutoff on the left here, so you will actually have 8 characters here for a proper binary decoding to ASCII. Now, it is possible to convert this with just 7 binary characters, but I like to stick to 8 because that's how characters are represented as bytes in the system. That being said, we're going to take this, and we're going to pull it over here, we're going to bring up our browser over here, and we're going to open up CyberChef. Now we're going to copy those binary digits line by line, starting with 0. We can't read the second line, so we'll go to the third line. Then the fourth line. And then the final line down here, because we can't see this line here. Now that we've gotten that done, let's do from binary. We get something that doesn't look to be very readable. Well, if we switch our input with the output, and we remove the %, we get something that looks like RST, the $ obviously representing an S. RST is a reset packet. If we look up RST, let's do packet. An RST packet is sent when an unexpected TCP packet arrives at a host. So this is a legitimate packet. Now, I don't know if it was actually intentional for them to have the binary decode to something like this, but it did inadvertently take us to the right answer. So what we're going to do is, instead of syn ACK P, we're going to do syn ACK RST, and we're going to click check on that. And now we can go on to mission level 6. We have another image. Go ahead and right click, save that image as. And I have it here in this directory, but we're going to navigate to it in our Kali box. I have the image right there, and all you need to do with the image is run strings on it. You're going to notice that there's some base64 text underneath the file trailer right here. You're just going to want to copy that and echo that into a base64 decoding utility. You can also use CyberChef if you want to, or whatever, it doesn't matter, as long as you have something that can decode the base64. And press enter. Not like it's hard to decrypt this, huh? The password is blah blah blah. So this is the password right here. We'll copy that, paste it here, click check. And now we can go on to mission level 7. Download the image here. So if you download it, you're going to get a zip file. If you unzip that zip file, you're going to get this .tif image right here. What I want you to do is open that image up in GIMP.
This is what it is, okay? I said empty your mind. Be formless.
If you get this error, just ignore it. Click keep here if this pops up, and just click X or OK to get rid of that. Now you're going to notice that there's 4 different layers to this image. I want you to hide the first layer. You're going to easily see your password right there. So we're going to go ahead and go back to our challenge page, and we're going to type that in. Click check when you're done. And now we can go on to mission level 8. We have yet another image. I want you to go ahead and save that. Then I want you to open this image in GIMP once again. Then go ahead and zoom in on the image. And there's a specific dialog box that I need you to have open. It's called the cursor dialog. And how you get it to show up if it's not showing up by default is you go to Windows, Dockable Dialogs, and then Pointer. Sorry, I said cursor, but I meant to say pointer. And this is going to be important here in a second. You're going to notice that there's a line of off-colored pixels down here that seemingly look like different shades of red. You're going to want to select your color picker tool right here and hover over each red pixel. You're going to notice in the dialog window over here, the R value is going to be a certain number. You can also look at the hex as well. Now these numbers we can decode to ASCII. So 112, 97, 115, 115 again, 119, 111, 114, 100, 61, 89, 114, 82, 111, 116, and finally 55 are all ordinates that can decode to readable plaintext ASCII. That being said, I've already done us the liberty of pulling out those values so I don't have to type them out. So we'll go ahead and copy those and we'll paste them into CyberChef. Then you're going to want to do from decimal or from hex if you decided to copy the hex values instead. And we get our password right here. So you're going to want to copy this part of the output, paste that into your password submission, click check, and we can move on to mission level 9. Download the song here, just click this link and it'll download this Stego 9 zip file. If you unzip that zip file, you'll get this ecstasy ATB music WAV file. What you want to do is once again open this in Sonic Visualizer. Then you're going to do layer, add spectrogram, all channels mixed. And if you zoom in, you're going to see what looks to be Morse code. Now, interestingly enough, in between each sequence, there's either a small space or a big space, which means that when we decode this Morse code, those big spaces and little spaces must be separating characters and maybe words. We don't know yet. But in any case, as you can see, the long lines are dashes and the little squares are dots. So all you need to do is copy that out to some sort of text document so that we can further decode it. Now, I've already done us the liberty of doing that. I copied out all the Morse code to this text document right here. And the little gaps you see in between the Morse code here are represented by spaces, and the big gaps are represented by new lines. So we're going to copy this to CyberChef. We're going to look for Morse code. From Morse code, and we see what looks to be decimal ordinates that we can decode to ASCII. So let's go ahead and switch the input with the output, get rid of this recipe, look up decimal here, do from decimal, and there's our password for this level. So copy and paste that into here, click check, and we can move on to the final Stego challenge for this video, mission level 10. I am not Shakespeare. Bacon is a cut of meat taken from the sides, belly, or back of a pig that has been cured, smoked, or both. Meat from other animals, such as beef, lamb, chicken, goat, or turkey, may also be cut, cured, or otherwise prepared to resemble bacon. Bacon may be eaten fried, baked, or grilled, or used as a minor ingredient to flavor dishes. The word is derived from the Old High German Backo, meaning back, ham, or bacon. Alright, so this image is clearly indicating that there's some sort of bacon cipher embedded or inside the image itself. And what a bacon cipher is simply a type of substitution cipher where each letter is encoded by a sequence of 5 A's or B's. That being said, where is the bacon cipher in this? Well, if you save the image to wherever you want, and you navigate to it, and you open it up in Paint, you're gonna notice that some of the letters are bold while others are not bold. Well, there's your pattern. The bolded letters could be A and the non-bolded letters could be B, or vice versa. It doesn't matter which letter you assign to the bolded or non-bolded because we can always swap them later if we need to. And the reason why I went on to the third line here, because only the first 2 lines here have noticeable bolded letters, is because I ended up with an encrypted string length that wasn't divisible by 5. Remember, it takes 5 A's or B's to make up 1 letter. So the length of our cipher must be divisible by 5. So that's why I went on to 2 extra characters here, as that gave me a cipher that was divisible by 5. And you'll see that here in a second when we actually decode it. Now, I've already drawn all the correct letters under the bold and not bold. Well, the letters may not be correct, but again, we can swap them, right? But as you can see, I have a 103 marked right here, and that's the number of characters that both these lines comprise of. Well, if I add 2 more characters, making this 105, that would make the entire cipher string divisible by 5, which we can properly decrypt. So I've already gone through the trouble of copying all these letters out to a text file, which you'll see right here in this bacon txt file. So all we're going to do is copy this, and we're going to go back to CyberChef. We're going to paste that in the input. We're going to look up bacon cipher decode. Obviously, our translation isn't 0 or 1. It's going to be A or B. And you're going to notice that you have some question marks here. That means that this did not decode properly. So it's quite possible that we need to swap the A's with the B's. So let's go ahead and do invert translation in order to do that. Now we don't have any more question marks, but this isn't readable. So what do? Well, we have another thing we can change here, which is the alphabet. We want to select complete instead of standard. And we get our password. It reads, the password is not here. You need to take this literally. The password literally is not here. So you're going to type that in lowercase with a space in between not and here. Click check. And we can go on to mission level 11 if we want to. However, that wraps it up for this video, as we were only going through the first 10 challenges. So, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comment section down below. This is Almond Milk. Thanks for watching. Goodbye, world.